Hey guys, this is Mr. Yo, and today we are gonna go over Unit 3 review guide. So a couple things that you need to remember for this topic is the periodic trend, electron configuration, charges, valence electrons, and so forth. So all these informations are on the list of topics that you need within that first sheet that I gave you guys during the first class of Unit 3. So here are a couple things you need to remember. First thing first, it says indicate where the S, P, D, and F blocks are located, including energy levels. So first thing first, we know that the first two columns right here are counted as the S sublevel. And also remember, this is also counted as the S sublevel as well. This is where the helium is, and that's where the S is as well. Now, next is this block, which we call it as the P block or P sublevels. Next, we have the D block or the D sublevel. And last but not least, we have the F sublevel as well. Now, for you guys on the test, you guys won't be dealing with the F sublevels as much. So I would focus more on the S, P, and D. Now, a couple things you need to know is that S always start out with the first energy level, and then second, third, fourth, fifth, sixth, and seventh. Now, for the P block, they start out from 2, 3, 4, 5, 6, 7. For the D sublevel, we start out with 3, 4, 5, and 6. Now, this might be TMI, but for the F sublevel would be 4 and 5. Now, the most important thing that you guys need to focus on are the S sublevel starts out with 1, P sublevel starts out with 2, and D starts with 3. So always keep that in mind when you're dealing with the electron configuration. Okay. And if you guys have any questions, feel free to look over the notes that I posted on Schoology. Okay. So let's move on to the next part. The next part, we have the following symbols. Now, before we move on to any of these informations, make sure to know the following. The number on the top left corner is called our mass number. This is something that is not located in your periodic table, but is something that is given to you majority of the time. Now, mass number can be found when you're doing proton plus neutron. Now, if we look at proton, the first thing we know is that magnesium is in the one with 12 protons, and you can figure that out in the periodic table. The neutrons, on the other hand, since we have 26 given to us as our mass number, all we got to do is subtract from proton to get our neutron, which is 14. Next, we have the electrons. Now, electrons are usually the same thing as protons. However, since our statement or question says 2+ charge, that means there are more proton than electron. But since we can't change the number of proton because it identifies the element, I'm going to subtract 2 from the 12 to get 10 electrons. Now, remember the time when I said plusy cat? So when you see the word cat, it kind of gives you a hint that it's going to be a positive charge, while anion is a negative charge. Which means when we have the 2+ charge in our statement, this is going to be a cation. Okay. Now, for the rest of the questions, I would like you to pause the video and try to solve those questions out if you have not done so. All right, so moving along to the next one, we have 33 protons for AS, We know 75 minus 33 will give you 42. The number of electron is by doing 33 plus 3 this time because it's a negative charge, so 36. And this is an anion since it's a negative charge. Next, we have calcium, which has 20. Now we do 40 minus 20 should give you 20. The charge of calcium or the electron would be 20 minus 2 to get 18. And this is a cation. Now, in the case on the right side, what we're trying to figure out is the symbol and if it's cation or anion. So we know that 11 is actually has an element of Na or sodium. The mass number would be adding these two numbers to get to 23. So we get 23 on the top left corner. Now, if we look between the 11 and 10, we know there is a positive 1 charge because we're 1 less electron short. So I'm going to put 1 plus. And since we know it's a plus sign, it is going to be cation. Okay. Then we have 15 for proton, which is phosphorus. Now, phosphorus, adding it all together, should give you 32 mass number. And if we do 18 minus 15, that should give you 3. But since we have 3 more electrons, I'm going to put 3 minus. That means since it's a minus charge, it is an ion. So keep that in mind when you're solving this question. If you have any questions, feel free to ask during line time, or I would say after school on Thursday for more information. Now, next we have the electron configuration. And also one more thing to add on. If you guys want to check your answers or want to pause the video along the way, please do so to get those answers. Okay. Even though I will post you guys the PDF file of the answer key. So next we have, let's choose blue. Next we have the electron configuration of sodium. So sodium has, first of all, it has how many electrons? Let's see, 2, 4, 10. There are 11 electrons, which in this case we know. We always start out with the 1s2. That's always the starting point. And since we have 11 electron, I'm going to move on to the second level where it starts with an s and 2 electrons. So far we have 4 electrons covered. Now, if we move on to the next one, which is 2p, maximum number of p electrons for p sublevel is 6. So now we have 10. And last but not least, we have the next level following with 1 more electron. So a couple of things you need to know about electron configuration is this is the one with the exponents. Okay, that's the number, not the arrow sign, but the exponents. And pause the video before, or if you guys want to try this out on your own. All right, so the answer for the next one is it's pretty long, but if you guys look at the periodic table that I've given in the electron configuration notes, I highly recommend it because there is a cheat sheet on it, which will help you identify why the last element, iron, is 3d6. Okay. Next, we have ruthenium, which is Ru, and the answer is going to be slightly longer compared to the other one. Okay. And there you have it. RU is actually below FE. So we know we're going to end with 4d6. And all you got to do is fill it in. Now you're going to probably ask, Mr. Yo, why can't we use the shortcut method? Well, now what we can do is use the shortcut method of the noble gases, which is shown below. So what we're going to do is for noble gas, there are 2 points that you need to remember. One is from the elements that you are given. Okay. I want you to go over or go to the previous. Okay, go to the previous row or period. So rows and periods are the same thing. Next, what I would like you to do is go to the noble gas. And this way we will know which noble gas to use. So strontium, if we look at strontium in the periodic table and go a row up and all the way to the right, you should get an element called krypton. And after you get to krypton, all you got to do is go step by step after krypton, which in this case is 5s2. And that's it. So I just want you to try out. Now, silver is Ag, not Hg. That was a typo. Try that out, and I'll reveal the answer afterward. So silver is going to have the same noble gas following with 5s2 and 4d9. Now, in an electron configuration proper way of solving it, this is not the correct answer. But for our case, we're not going to do a special case, but we're just going to keep this as our answer, because this is how I taught you guys in class. Okay. So there you go. So now let's move on to the next question. The next question is about orbital diagram. So what I meant by orbital diagram is that it's the arrow signs, if you guys remember. Okay. Now there are 2 ways to do this. One way, well, first of all, I need to figure out the number of electrons within carbon. And we know there's 6. And I'm just going to write down the electron configuration for that element. Here's the reason why. Remember that the numbers on the exponent represents the arrow signs. So there are 2 ways you can do this. One way is you can write down the boxes right next to each of these sublevels. Okay. And remember, P has 3. Or you can put it as the underline. Either one of these methods would be totally fine. Just choose one of them. That's all. So we know 1s has 2 electrons. So I'm going to put 1, 2. 2s has 2 electrons. So I'm going to put 1, 2. Now 2p, on the other hand, has 2 electrons. So I'm going to put 1 and 2, not next to each other, because it will break the Huns rule, which I will talk later on. Now, another way you can write down on the next one is pretty much the same thing, but I'm just going to put just like that. Okay, so pause the video and try out the next question on your own. All right, so for oxygen, your answer should be either one of these choices. And if you get both of them or one of these answers, you are good to go with the test. And I know this was one of the concepts that we struggled on, but if you guys understand it, that's good. And there you have it. That is your answer. Now pause the video if you'd like to catch up with the answers. All right, so for a Pauli exclusion principle, what it basically means is when you have an orbital or a box, we always have to make sure that we have an arrow sign going up and the arrow sign going down. So it's an opposite spin. So opposite spin. Always remember that. We can't have a situation where it's both up or both down. That is totally wrong. So always keep that in mind. Oops. Okay, spin. Now, like I said, these are incorrect. So do not copy this down, but always make sure one goes up, one goes down. Next, we have the Authbah Principle, which means in order. So always remember that, the word order. So if I give you an example like 1s2, 2p6, and 2s2, we know something is wrong because we know S always goes before the P. So in this case, we know the one that I just wrote down was wrong, but these have to switch places. So the correct answer would be 1s2, 2s2, and 2p6. The Huns Rule, on the other hand, is pretty simple because all it's basically saying is make sure if you have multiple orbitals, so like the P block or the D block, make sure to fill in one in each boxes, one electrons up arrow signs in each boxes first before going back and drawing the bottom arrows or going down arrows. So this would be correct, but this is incorrect. So keep that in mind when you guys are dealing with this rule. Okay, you don't have to know the exact definitions of it, but just understand the visualization of these concepts. Okay. Now, I know this is the recent subject that we went over from last class or so. A couple things I want you guys to know is plug in the right number. Don't put random numbers, but plug into the right numbers. It's pretty simple. All you got to do is plug it in, solve for the answer or solve for the missing variable, and get the answer. So here's a case. Whenever you're solving this question, I would like you guys to kind of underline the important facts so you know which equations you will use to solve for the question. I'll provide the equation and the constant numbers in class so that you can use that for your advantage on the test. So number 7, it says, what is the frequency, that's a keyword, of a wave with a wavelength of 100 meters? Now, since we have frequency, which is kind of like a V shape, and wavelength, that looks like a wishbone or lambda. So in this case, the equation we'll use is C equals lambda V. So all you got to do, like I said, is plug it in. So we know C is 3.00 times 10 to the 8th power equals, we're looking for frequency, but the wavelength is 100 meters with a V. Now, how do we look for that missing variable? Well, obvious. If we know that these are being multiplied, what is the opposite of multiplication? Division. So all you got to do is divide and get the answer. So if you do that, you should get the answer of this. Now, this is shown if you plug it into the calculator. But I know I taught you guys the scientific notation, and to do so, all you got to do is move the decimal, the invisible decimal on the right, all the way till you reach to this part, the number that is less than 10 but greater than 1. So our answer will come out to be 3 times 10 to the 6th power. Now you might say, or we always have to make sure about the sig fig, so that's why I used this 1 right here. And since we have no decimal, this is 1 sig fig. So that's why our answer is 1 sig fig. Now the unit is going to be hertz or 1 over S. If you get either one of those units, you are correct. So try out the rest of the questions on your own. Pause the video, and I will reveal the answers once you guys are ready to move on. Okay. So next, number 8, it says energy, frequency, and that's it. So we're using the equation E equals HV. We don't know the energy, so we know the H value, which is 6.626 times 10 to the negative 34 times our frequency, which is 4.3 times 10 to the 7th power. All you got to do, just plug it in to the calculator. So that should give you this as your answer. Okay. Next one, let me use a different color. We have frequency and a wavelength of this. So we know it's going to be C equals lambda V. 3.00 times 10 to the 8th power equals 2.4 times 10 to the negative 8 times V. So our V, you know, we have to divide on both sides the same number. Okay. And that should give you the answer of 1.3 times 10 to the 16th Hz. There you go. So feel free to pause the video for to catch up. Now for the next one, number 10 is a two-step process. What we're going to do is we're going to use both E equals HV and C equals lambda V. The reason why is because we have energy and wavelength. And we know wavelength is not actually in the E equation. So what we're going to do is look at the two equations and see the similarity between those two, which is the V's. So we're going to solve for the frequency and plug it in to the E equation. So first thing first, I'm going to use the C equals wavelength and look for the V. If our V ends up getting 7.5 times 10 to the 15 hertz, I'm going to plug that into the E equation. Okay. So once you plug that in and solve for the answer, you should be able to get 5.0 times 10 to the negative 18 joules. Okay. And there you have it. So feel free to look back on the other or go to the previous sections and be able to solve each of these questions thoroughly, because definitely these questions will be on the test. All right, so moving along to the next question, we have number 11. Number 11 is one of the packets that I gave you, the 3 packets. This is the one with the picture that I told you guys to read on your own. Now, basically what it's saying is, what happens when an electron absorbs an energy? Now I'm going to show you a two picture. One is a descriptive picture, while the other one is more of a just easy to see. So right now we have a random electron. Let's say there is an electron here. Now, if there is an energy going in to the atom, so let's say this is energy. What happens is, right now, this circle that we have is called a ground state because it's in the inner side of the orbital. Okay, let me just rewrite that down. Next, what's going to happen is that this is actually going to transfer up once it receives the energy. So it's going to be on the line. And this is an example called an excited state. Okay. And each of these circles represents the energy level. So I just labeled every single thing you need to know. And this is what it looks like. So if I were to redraw this, okay, make it in a way that you guys can actually see it, it's basically saying electron going up while energy is coming in. Okay. So if I were to write this as a statement, basically what I'm going to say is when an electron absorbs, oops, that's not what I was meant to do, absorbs, okay, energy, it goes from ground state to excited state. Okay, that would be the statement for this number 11. Now, moving along to number 12, it says, draw the visible spectrum and label the colors in order from highest energy to the lowest energy. How in the world am I going to do this? Well, first thing first, we know the rho G BIV that you guys have learned since elementary school. Now, since we're looking from the highest energy to the lowest energy, okay, I'm going to start out with violet because it's darker. So violet usually has a higher frequency, which means higher energy. Next is indigo, then blue, then green, then yellow, orange, and red. Okay, so it's kind of a reverse of rho G BIV, but that is the pattern for the highest to lowest energy. So having that mindset that we just talked about for number 13, we mentioned that the higher the energy, the higher the frequency, which also means the lower the wavelength. So this is the pattern you need to know. Okay. So if we look at the blue light, if we compare with blue and red light, blue actually has, this letter B, has shorter wavelength and higher frequency. And that is why letter B is the right answer to this question. Okay. So feel free to pause the video just to catch up. And let's move on. So number 14, it says, if an element gains an electron, it has a what? So if we gain electron, it's going to have a negative charge. And we said if it's a negative charge, that's going to be an ion. Keep that in mind. Next, explain the difference in atomic radius of nuclear atom and its cation. Why does this occur? So we haven't actually talked much about this one, but it's a very simple question. Basically saying, if we have an atom that has one electron, okay, let's say this is the neutral atom. Okay. Now, if we lose an electron, what happened? Well, one of our orbital will disappear, or energy level, because we lost an electron. So that means the cation is smaller than the neutral atom. Okay. As it loses an electron. Okay. Or usually we can say the energy level as well. Okay. Now explain the difference in atomic radius if the neutral atom and its anion. So this time, instead of having a, let's say this is neutral as always, we're gaining electron. We're going to have more energy orbital going in. In another word, anion, okay, is bigger than neutral atom. As it gains an electron. Okay. That's basically what it's saying. So if we lose electron, we lose energy level, or it gets smaller. We gain electron, then we are going to have a bigger than the neutral atom. So that is something that you guys need to know. It's pretty simple. So keep that in mind when you guys are going over the study guide. All right, so now let's talk about the periodic trend. So electronegativity. Here's a very simple definition of electronegativity. It's basically the energy to gain electron. Pretty simple. Now for the test, I'm not going to explain or ask you guys a specific definition of it, but I just want you guys to know the trend. So we know as we go from left to right or bottom to top, it increases. This would be another way as well, going top right diagonally up. That would be another way to remember. Now, if we talk about the highest electronegativity, okay, this might be an extra information. Electronegativity, the highest element in this case is fluorine. Now, you might ask, why isn't it not helium? Because it's in the top left corner or top right corner of the periodic table. Well, technically, it has 8 valence electron or 2 valence electron in special case for helium. That means we won't be gaining more electron. It's done. So that is the reason why it does not, or helium does not, or cannot be the highest electronegativity element. So that is why this cannot be the right one. Now, I just want you guys to try out the last 2 questions that are given to you. Just circle the right answer, and that is it. And we can move on to the next trend. So pause the video and go for it. All right, so the answer is oxygen and nitrogen. Okay, and you guys probably can see that by using the periodic table. Now, atomic radius. Atomic radius is talking about the size, or another way is the distance between, between nucleus and valence electron. Okay. Now, the pattern is as it goes down the periodic table and to the left, it increases. So it kind of shows it diagonally to the left, bottom left corner. Now, the reason why this is occurring is because we talked about having in each energy level contains the number of circles or energy levels. So as we go down the periodic table, the circle gets bigger. But doesn't that mean it increases to the right because it has more electron? Well, technically, if you guys remember, left to right has the same number of energy level, which means same number of circles. But if we have 7 valence electron on the right and 1 valence electron on the left, the one with the 7, okay, the one with the 7 would most likely want to get more closer to the nucleus because there's more electrons. So that means the size will get smaller. So in reverse of it, the one with 1 valence electron will become larger than the one with 7. So that is the reason why this trend is correct. So now what I would like you guys to do is try the next question, pause the video, and we'll go over. Okay, so the next one, the biggest or the easiest way that I would do is label smallest and biggest on the left and right, just to kind of, just to avoid any mistakes. So for the first question, the answer will be Li, Na, and Rb. The next question is going to be Br, Ga, and Ca. Okay, and there you go. Now, the next trend or the final trend is called the ionization energy. Now, what is that? It's basically the energy to lose electrons or remove electrons. Energy to remove electrons. So if we're talking about removing electrons, it's the same pattern as electronegativity. It increases as you go that direction. Now, the highest ionization energy in this case is going to be helium. Now, the reason why helium, my apologies, it should be lowercase e. The reason why it's helium is because, remember, we're removing electron, not gaining electron. So that's why for this one, ionization energy will be, the highest element would be helium. So try the question again for this one. And like I said, mark it. If it's decreasing, put the largest on the left and smallest on the right. Okay, and then start trying the problems. So here's the answer for the following questions. We have Mg, Ca, Mba, P, Si, Na. If you don't know the reason why, I'm highly recommend you to look at the periodic trend notes. Okay, it's in your Schoology. So look at the labels in the Unit 3 folder, and it should help you guys to guide through the topics. So feel free to pause the video and go over those notes if necessary. Now we're almost done. The last part is labeling the following information. So right now we have a periodic table that's written on the bottom. Now, one thing I'm going to label on the bottom is that transition metal here. So I know it's not mentioned here, but that's where the transition metal is located. Now going back, if we look at the periodic table, we know the answer is going to be 1, 2, 13, 14, 15, 16, 17, and 18. That is literally written on the periodic table. If you don't know the answer to it, get used to understanding the periodic table. The valence electron, on the other hand, so these are informations that you can find from the flip book back when we were doing Unit 1. It should help you tremendously when you guys are going over this information. Valence electron, we start out with 1, 2, 3, 4, 5, 6, 7, and 8. So an easier way that I will remember is that if you have group 13, take out the 10 digit, and that will be 3. Take out the 10 digit, 4, 5, 6, and so on. So that would be a good way to remember the valence electron. So remember, valence electron doesn't have a positive or a negative charge. Okay. Then let's move on to the next part. Now, how do we know if they're going to lose or gain electron? That's also in the flip book. So the first column will have +1, then +2, +3. The 14th column actually has its own special case, which is both positive and negative charge. Then -3, -2, -1, and 0. Now, remember, the plus charge means losing electron. So I'm going to label as lose, lose, lose. I'm going to leave the plus and minus for blank because it's technically both. And then gain, gain, and gain. Okay. And the zero charge will be no charge, which means there's no positive or negative. So I'm going to leave it as it is. And then determine if it's cation or anion. This is so simple for you guys. Cation is positive, anion is negative. And just like I said, I'm going to skip this one, plus and minus, because it's both anion, anion, anion. Now, if we have no charge, there's no positive or negative charge. Now, the next or last column or row is talking about the part when we talked about the neutral atom. So we know if we have a positive charge, this will be a smaller size. Smaller. Okay, smaller. Skip. And bigger as it goes negative. There you go. All right, so I will post this video on Schoology for you guys. If you guys have any questions, feel free to come after school on Thursday. And I know the test is on Friday and on Monday, so the 12th and the 15th. So feel free to look at this video as a review. And if you have any questions, feel free to email me, or we can set up a Zoom meeting if necessary or if needed. So good luck with your study and hope you guys ace the test. And good luck.